Welcome to part 12 of Fastenation. Today we're going to look at machine screws, machine bolts, and machine nuts. We're going to talk a little bit about the application or how to use these for function, the anatomy, which will include how to describe the diameter, length, and thread pitch or frequency of occurrence of threads on those components. We're going to look at some specialty fasteners that are used for holding and hanging and joining dissimilar materials. And then we're also going to look at how we're able to cut our own internal threads and external threads on different types of metal stock. So on the table, we have examples of a host of different types of bolts, nuts, washers, and the wrenches that are associated with driving or tightening these fasteners together. You're going to see some examples of common applications of machine threads on simple mechanical devices like we have here and here and here. Some different applications of mechanical fasteners that are providing us with that combination of the function and aesthetics that are consistent between the application of the hardware and the object itself. We're going to look at combining dissimilar materials like rigid materials like this 1/4-inch steel plate with materials like this rubber base that is bolted onto this piece. And again, last but not least, we'll go into some detail about how we're able to use taps for cutting internal threads inside of metal stock and dies for creating external threads. In our first module, when we talked about nails, we found it useful to be able to describe that nail in terms of its diameter, its length, and the head profile. When we got into our module where we started talking about wood screws and sheet metal screws, we added to that conversation drive styles or drive systems. Now, when we look at machine screws, we're still talking about length, width, different drive styles, but now we're going to introduce the variable of the number of threads per inch that are commonly found on mechanical fasteners like machine screws and nuts and bolts. It's important for us to be able to describe these relationships because there are specific correspondence that are required between these different components. And the easiest way to think about this is that there are two basic standards when it comes to the frequency of the occurrence of threads on machine screws, nuts, and bolts. Those two standards are national coarse and national fine. In the in fasteners smaller than 1/4 of an inch, we're using a numerical designation like we did with the wood screws. So the common numerical designations go as low as 0, but the ones that you'll commonly find in machine screws are number 6s, number 8s, number 10s, and number 12s. From there, the most common fractions that occur are 1/4 inch, 3/8, 5/16, 7/16, 1/2 inch, and so on and so forth. Each of these different fasteners will have that size repeated with a variable number of threads per inch depending on whether it's National Coarse, NC, or National Fine, NF. And you can see a couple of examples of that here on the table, but I think that it would be beneficial for us to move in for a closer look before we go further in describing those differences. Number 6, number 8, number 6, number 8, and number 8. Now, although these are both number 8 screws, you can see that the frequency of the occurrence of threads is greater on this screw than it is on this screw. So that is a number 8, 32, and this is a number 8, 24. So in the same size, you'll almost always have at least 2 distinct thread pitches. In 1/4 inch diameter fasteners, you'll frequently find 20 threads per inch as the most common fastener in that 1/4 inch diameter, although they're also available in a fine thread, which is a 1/4 28. The reason for the variable occurrence of the threads is that when we are establishing internal threads in a piece of material that we want to have a sheet metal screw affixed to, the rule of thumb is that you need a minimum of 3 of those threads in contact with the cross section of the material that you're creating internal threads in. So let's take the 1/4 20 as an example and see how the rule of 3 applies to that. If a 1/4 20 has 20 threads per inch, then that means that it has 10 threads per 1/2 inch, 5 threads per 1/4 inch, and 2.5 threads per 1/8 inch. So we know that because of the rule of 3, that 1/8 inch material does not have enough thickness of cross section to meet that standard of the rule of 3. But if I chose a 1/4 28 instead of a 1/4 20, then 28 threads per inch, 14 threads per 1/2 inch, 7 threads per 1/4 inch, and that gives us 3.5 threads per 1/8 inch, which meets that standard. Many of the bolts that you see here are what are called partially threaded bolts. And the reason that bolts will often have different proportional relationships between the number or the length of the bolt that is threaded has to do with how those bolts are applied. So when you're trying to gather up a volume of material and secure it in place with a nut, or possibly a combination of a nut and a washer, then you don't want the threads coming in contact with the body that bolt is passing through, because the threads would have a tendency to mar and tear up that hole or opening. So bolts that are not fully threaded are designed to be able to pass through a piece of material, only extending out enough of the threaded portion to be able to secure a nut, a washer, or whatever combination